So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is maximum level sum of a binary tree. So given the root of a binary tree, the level of its root is 1. The level of its children is 2, and so on. Return the smallest level x such that the sum of all values of nodes at level x is maximum. So pretty much simple problem to understand. The question is saying that you are given a binary tree and its level start with root as level 1 and the level subsequently increases, and it is follows like this. It is level 2, this is level 3, and if there would be further nodes then it would be level 4 and so on. Now you need to calculate sum of nodes at each level. So this level has sum 7, this level has sum -1, this level has sum 1. So you need to calculate the sum, and whatever is the maximum sum at a level, you need to return that level. So in this case, in which level we get the maximum sum? We get the maximum sum as 7, which is at level 2. So we'll be returning 2 as our answer. So you can see we are returning 2 as our answer. So pretty much easy problem to understand, and the approach is also simple. Now can you tell me, like, in this question what is happening? We are doing level wise traversal. Level wise traversal. So which algorithm should we use which is able to do the level wise traversal? It is simple. We can use BFS because it is level wise, it does the level wise traversal, and with the help of BFS we can keep sum at each and every level, and we will just compare what is the maximum sum we are getting, and for that we will just return its particular level. So let us see with the help of first example how we will be running the BFS and all of that. So this is the first example that I have drawn. So this is level 1, this is level 2, and this is level 3. So I have kept a queue for the BFS traversal, and I have declared 4 variables: max sum, sum, level, and max sum level. So this max sum will denote the maximum sum that we have. This sum will be the current sum at the level. This level will denote at what level we are traversing, and this max sum level will denote at what level we are getting the maximum sum. So first of all, we will be traversing from the root element. So root element is 1, so we will push 1 into our queue. So this current level has size 1, so we will be iterating for this level 1 number of time. So we will be coming at this particular level, and at this level we have the node 1, so we will pop this 1 from our queue and we will add it to our sum. So sum will become 1. Now we will check whether this 1 has child nodes or not. So yes, 1 has child node as 7 and 0, so we will push 7 and 0 into our queue. Now we will check whether this sum that we have currently is greater than the max sum or not. So max sum is int min and current sum is 1. So yes, it is greater than the maximum sum. So we will just update our max sum with 1, and yes, we will move forward. Now since we are updating our maximum sum, so we will also update the maximum sum level, right? So yes, if we are getting a new maximum sum, so we will update the maximum sum level by the current level. Now since I already initialized the maximum level by 1, so in this case we don't need to update, but yeah, still for the simplicity we can just update the maximum level with the current level, that is 1. Now we'll be coming on to this level 2. So level 2 has 2 elements, that is 7 and 0. So we'll be iterating on them one by one. So we'll be iterating on this level 2 number of times because we have 2 elements. So first we will pop 7 out, and obviously at the new level our sum will again be reset to 0. So we will pop 7 out and we will add 7 to our current sum. So our current sum is 7. Now we will check whether this 7 has some child node or not. So yes, 7 has child node as 7 and -8. So we will push 7 and -8 into our queue. Now we will be moving on to this next element 0. So we'll be popping 0 out from the queue and we will add 0 to the sum. So our sum will remain unchanged. So our sum will be 7 only. And yeah, obviously before coming on to the next level, we will update the level also by +1, that is level 2. So we have traversed this particular level because we have iterated on both the elements. So we will compare whether our current sum is greater than the max sum or not. So our max sum is 1 and current sum is 7. So yes, it is greater. So we will update our max sum by 7. And yes, we can say that if our maximum sum is getting updated, so our max sum level should also be updated. So we will check at what level this maximum sum is we are getting. So we will be getting the maximum sum at the current level. So current level is 2. So we will just update the maximum sum level by 2. So at level 2 we are getting the maximum sum as 7. So this is what we'll be doing in the level 2. Now we are coming at to the level 3. So we will update this level 2 by level 3 and we will reset our sum with 0. Now we are at level 3. So level 3 has 2 elements. So we will be iterating level 3 2 number of, or like we will be continuing our iteration for 2 number of time. One for this element 7 and then for this element minus 8. So we are at level 3. So sum is set to 0, level is updated to 3, and yes, we are good to go with the traversal for the level 3. So first we will pick out this element 7 from the queue. So we will just pop this element out and add it to our sum. So sum will now become 7. Now we will check whether this 7 has some right and left element or not, so that we can get to know if we have child element or not. So no, 7 doesn't have any child element, so we don't push anything into our queue. So now we will just move forward to the next element, that is minus 8. So we'll pop minus 8 from our queue and we will just add it to our current sum. So our current sum will now become minus 1. So now we have successfully popped out 8 also. So now we will check whether this minus 8 element has its child element or not. So no, minus 8 doesn't have any child element, so we won't push anything into our queue. So now after this we will check whether this current sum is greater than the maximum sum or not. So current sum is minus 1 and maximum sum is 7. So no, it is not greater than 7. So we won't update our maximum sum level also, because we didn't update our maximum sum. So we have successfully completed the iteration because now we don't have any element left into our queue. So we can say that our answer would be the maximum sum level, which is 2. So we'll be returning 2. And if you can see the like the example test case, like this, yes, so here also the output was 2. So this is how we'll be doing with the help of BFS traversal. So I hope you understand this particular solution. So let us see directly the code now. So yeah, this is the code. So first we are declaring a queue and we are pushing the root element into our queue. We are initializing the maximum sum level by 1, the current level by 1, maximum sum by int min. Now we are iterating the entire queue until our queue becomes empty. So while our queue becomes empty, we'll be doing the following operation. So we are initializing a sum variable which will set to 0 after each and every level. So I have declared a n variable which will be telling the current level size. So if the current size is 2, that means we need to iterate on 2 elements. So n will be depicting the size of the current level. So while we are iterating on the current level, we will get the front element and we will pop that element, because now after this we won't traverse it again. So we'll be just popping it out from the queue. So now whatever the value this node has, we will just add it to our sum and we will check whether this current node has some child element or not. So for that we can check if the current has some left value, push that current left into our queue. If the current right has some value, so just push that current's right value into our queue. After the successfully iteration of this entire level, we will check if our sum is greater than the max sum. If yes, we will update the max sum by sum and max sum level by the current level. After this current level iteration, we will just update the level by 1 so that we can iterate on to the next level. So if the level was 2, now we will update it by 1 so that we can traverse for the level 3 again. So in the end, we are just returning the maximum sum level, which will tell at what level we are getting the max sum. So this was about this particular problem. So I hope you understand this solution. Thank you for watching.